A very good morning to one and all. Now I am going to present a PPT on the topic of error detecting mechanisms and functions of SONET layer. Let me talk about error detecting mechanisms. What is meant by error detecting mechanisms? It is nothing but while you are transmitting a data from the sender to the receiver, the error will be occur or might be occur. That error will be detected using the three types of mechanisms. First one is parity checker. So simple parity check. It is nothing but if the data is transmitted from the source, then the parity bit is added to the data to check whether the error is occurred or not at the receiver side. So if the data contains an even number of ones means the parity bit is 0 is added. If the data contains odd number of ones means the parity bit 1 is added to make it as even parity. So this is nothing but even parity checking. Let me see through the example. Here the sender sends a data 1000111. The sender data has only 3 number of ones. So we have to compute the parity bit, that is 1, to make it as an even number of ones. It is transmitted through the transmission medium, and the original data that will be received by the receiver is 1 triple times of 0 and 1 1 1. Along with the parity bit, the receiver can able to receive the data, and at the receiver side they compute the parity bit, which is 1. So if the total number of ones in the data which is received by the receiver is even means the data is accepted by the receiver. This is all about even parity checker. Another one is checksum. So in the checksum error detection scheme, the data is divided into k segments. That is nothing but if you have a n number of bits, the data is divided into k segments which has an equal number of m bits. Let me see through the example at the next slide. So that segment should be added using the ones complement arithmetic. Finally you will get the sum. That sum is complemented to get the checksum, and along with the checksum the data segments are transmitted to the transmission media and it will be received by the receiver. So at the receiver side the segments along with the checksum are added using ones complement arithmetic to get the sum. Finally the sum is complemented. If the result is 0 means the data is accepted. Let me see through the example. This is the original data which has 4 segments, each of 8 bits. These segments are added one by one. First 2 segments are added, you will get the result, and the result has a carry of 1. So you have to add that carry to the result and you will get the final result. That is added with the third segment and you will get the carry as 0. So no need to add 1 to that result. You directly add the fourth segment to that result and you will get the 1 again as the carry, and you will add the 1 to that result which is obtained, and finally you will get the sum. The sum is complemented to get the checksum. At the receiver side, first you have to do the same operation as you done in the sender, and you will get the result. While adding a first and second segment you will get this result and you will add 1 to that one, and you will add the third segment to that result, and finally will add the fourth segment. You will get the result as sum. Before the sum you have to add the checksum. Okay, so you will get the sum. If the sum is complemented, then the result is 0. So the conclusion is nothing but the receiver can able to accept the data. The data doesn't have any error. Another one is cyclic redundancy bits. Unlike checksum scheme which is based on addition, here we are going to perform binary division. So in a CRC, a sequence of redundant bits, that is called cyclic redundancy check bits, or appended to add at the end of the data. If the original data is given, we have to add the zeros to the original data. That will, while after adding the zeros to the end of the original data, it will be divisible by the predetermined binary number. At the destination, the data is divided by the same number. If you have the remainder is 0, then the data is accepted, otherwise it should be rejected. Here there is a flowchart of CRC method. First, M is the data, original data, N is the number of bits which is appended to the end of the data, and D is the divisor which has n plus 1 bits. If the CRC bit is n bits, means the divisor is n plus 1 bits. So after performing the division, the data with the CRC bits is given to the receiver. At the receiver side also the same method is performs. At the time you will get the remainder as 0, means the data is accepted. Let me see through the example. The original message is 101 4 times of 00. If here we have to generate the polynomial, that is x cube plus 1, it should be written as 1 dot x cube plus 0 dot x square plus 0 dot x power 1 plus 1 dot x naught. The CRC generator has nothing but the circled things are the CRC generator, that is 4 bits 10001. Here the CRC bit is 4 bit, so the n minus 1 zeros are added to the end of the original bit. So only here we add 3 zeros at the end of the original data, and the divisor is nothing but the CRC generator bits, that is the 4 bit. Here we have to do the XOR operations. Finally doing the XOR operations, you will get the result, that is 00011. So that should be added to the original data. That should be added to the original data. This data is received through the receiver, received through the transmission medium to the receiver. At the receiver side also there will be doing the same operations. Finally if you get the remainder as 0, means so the result, the data should be accepted, otherwise the data is rejected. Another topic is synchronous optical network. The synchronous optical network is nothing but it is the optical transmission interface. This synchronous optical network requires a single clock. Why it requires a clock means for to handle the time synchronization. Basically the synchronous optical network is a time division multiplexing system. Let us see the functional layers of the SONET. There are 4 layers. Path layer, line layer, section layer comes under the data link layer, and photonic layer comes under the physical layer. First one is path layer. It is responsible for the movement of signals from its optical source to the optical destination. The path layer is nothing but it is responsible for moving the signals from source to destination. Here the device which provides the path layer functions is STS multiplexer or demultiplexer. Multiplexer means which multiplexes the signals at the input side, and it converts the electrical signal to optical signal. Demultiplexer is nothing but it demultiplexes the signals into various destination signals, and it converts the optical signal to the electrical signal. And second layer is line layer. It is responsible for the movement of signal across a physical line. Here the devices which are used is STS multiplexer or demultiplexer, add or drop multiplexer, provides line layer functions. Why we are using add or drop multiplexer? Now it will add or drop the signals while the signal is transmitting through the physical line. And section layer, it is responsible for movement of signal across a physical section. In the network, each device provides with the section layer functions, and the device which is used is regenerator. It is nothing but it is a repeater that takes an optical signal and regenerates it. Okay, the signals are processed through a number of regenerators or repeaters while traveling from the source to the destination. Finally, photonic layer, it corresponds to the physical layer of the OSI model. It includes physical specification for the optical fiber channel. If in the fiber channel the light is present, means it will show the data as 1, and in the absence of light it will show the data as 0. Thank you.